Hello, I am Miren Juaristi, researcher at URAC Research, and as part of CIRAF project, I am developing an innovative adaptive opaque facade that is able to minimize or maximize the thermal heat flux. We have proven through thermal characterization tests that we have this adaptive behavior in the facade, but now, before we go for a pilot building, we need to make sure that this is safe. To do so, we are here at the Fire Safety Lab of Tecnalia to meet the expert Xavier Olano, who will guide us in the innovation journey to make sure that this facade is safe. So let's go to meet him. So Xavier, I want to explain a bit what CIRAF is about so that we understand the test that we need to perform to ensure that this technology is also safe. And the main components are on the one hand, the active insulation system made of biopolyurethane. So it's like a regular polyurethane insulation material, but in this case, we have natural oils in its composition. Another innovative aspect of this active insulation panel is the fact that we have some channels in the surface of the insulation in both sides. Why? Because in these channels, we will decide when the air is flowing, and we flow this air thanks to two ventilators that we put in the inside part of this panel. And then we have a kinetic cladding. So it's a movable element that decides, we can manage it so that we decide when we want the solar irradiation go to this black layer and what's not. So we can control this with a control logic, and we decide when to move the kinetic cladding and when to act the ventilator. So this is our innovative system. And what do you think about this technology that has adaptive thermal behavior? Which are the challenges in fire?
I would say that looking at the solution, first we have this cladding element that will be in the first barrier to the fire. Mm-hmm. So it's important to see which material are we using and also the part of the joints between these cladding materials. Also behind that, we have also a cavity that usually it's like a tricky part because it can create a chimney effect that is also relevant for the outcome of the test. And finally, this insulation material, together with a very high absorptive material that is the aluminum, also can give us some issues. So I think all those three measures are something that we need to evaluate, and that will be key for the test.
Okay, so what do we need to do now to see that this product is safe
Now
enough?
I think we need to, let's say, configure the sample.
Okay.
That it's an L-shaped corner that has some dimensions.
Okay, so I will ask my colleagues to build the prototype so that we can do this test. And what about the material? Do we need to do some tests at material level also?
Yeah, I would say that it's always desirable, especially if you are doing innovative materials like biopolyurethane, to do some kind of preliminary tests in order to see where are they in terms of fire behavior. So maybe we can, for example, this insulation that seems very innovative, we can have some kind of test to have a first, let's say, idea of how it will behave. So maybe we can do a concalorimeter test that is very easy and simple and gives you a lot of information of the future performance of the material.
Okay, so I send you the material, the prototypes, and then let's do this test. And are these tests enough to characterize the innovation and to make sure that it's going to be safe? Or
well, I would say that they are part of the evaluation, because when we talk about passive fire safety, we have different concepts that I think it's important to understand. For example, when we talk about fire reaction, it's the contribution of a product of a material to a fire in terms of heat release, smoke generation, flaming droplets, and so on. When we talk about fire resistance, it's how much time the solutions around, like walls, doors, slabs, and so on, are able to stop the fire or contain the fire. And when we talk about fire propagation, is once this containment is breached, this fire will go along the facade, and we want to see how it spreads in the vertical of the building.
Okay, and just one doubt. The kinetic cladding, how do we position the louvers? Because this is a movable element, but with the fire
Yeah.
it would stop moving.
I will say that for this particular test, it's better to put it in a close position, because there we will have the flames will affect to more area of the kinetic cladding.
Okay, so
Because if it's open, it's not affecting to the whole cladding, but if it's in close position, it will be more onerous for the test.
okay, and we also have the stack effect, so it's the most challenging scenario.
Yeah, that's it.
Okay,
Usually, the best thing is to start with the most onerous configuration, and then maybe you can have better solutions.
perfect. So let's test it.
Okay.
So what are we going to see here, Xavier?
Yeah, so now we are actually doing a test.
Wow.
So here we are in front of the concalorimeter. That is a very typical equipment for fire reaction. And here, what we basically do is to place the sample here, and we have a cone radiating heat. So the material will start to release some gases, and finally it will ignite. So once the ignition starts, we are going to collect all the smoke of the combustion through these ducts. And here we have this element here, this device, that is measuring the opacity of the smoke and the smoke production. And finally, also, we have some tube that is taking a sample of the gas in order to evaluate the oxygen content. Because this concalorimeter works with oxygen consumption calorimetry, where we get the oxygen consumption, and finally, this consumption gives us an idea of how much heat we are releasing with the sample.
Okay, Xavier, so we brought, as you request, the prototype of CIRAF with the kinetic cladding and then the active insulation system. So what are we going to see in this test?
So here we are going to perform an SBI test that, to understand the scenario, is like a paper basket that is catching fire. So imagine that this is the walls of your room, and you have a paper basket here that will burn, and we want to see how this fire affects to the solution. So we'll see how this cladding could add heat or release smoke. Also, we'll see the performance of the cavity behind, and also the materials that are in the rear part. Okay, so now what we're going to do is to take the sample and put it in the sample holder right here, and then we will start with the test. Okay, so here is where we are going to place our sample, and we are going to do different measurements. For example, for this fire reaction test, it's important to measure the heat release. All the smoke is collected in this hood, and we are taking some samples in order to see how much heat we are releasing in the test, and also how much smoke we are generating. And these are the relevant parameters for the reaction to fire, both the heat release and the smoke generation. And finally, we are also measuring the flaming droplets, because if there are flaming droplets, you can have additional fires in the test.
I see. So where we are and what are we going to do here, Xavier?
Okay, so now here we are in the small flame or ignitability test. So the idea here is we will place a part of the facade in a vertical position, and we will apply a small flame here, like a match or a lighter. And the idea is we put like a line here, and we want to see how fast this flame can go through the sample. And this gives you an idea of how ignitable is a material. And this is also part of the necessary test for classification. If we talk about Euro classes, for example, for class A2 and D, you need to perform an SBI test that we saw before, and also a ignitability test.
So, Xavier, we have seen here how the technology behaves, the kinetic cladding material, also the joints. We learned some things that we should improve. And after that, we reach this level of optimization. What would be next?
Next will be to evaluate the system in a real scale level. So we are going to the next laboratory, that is our large scale laboratory. So, and there we will see how all the system behaves in case of fire. So let's go for it.
Okay, great.
So this is our large-scale testing laboratory where we perform this kind of facade propagation test. And here the idea is always the same. Here, as you can see, we have like a low floor where we create a fire that is representing a fully developed fire in a room. So imagine that this fire, like the SBI, has gone bigger and bigger, and all the room is on fire. And this fire is trying to break a passage in the facade, usually a window. So this will be representing this hole here, and then the fire will go out. And the idea is to see how this fire spreads along the facade. So we are measuring different temperatures in different levels, and also we are recording all the tests to see if there is some material falling down or if there is some collapse of the facade system, and so on. So it's a very realistic fire scenario, and we can see many other things that we cannot see in a material or product level, as we saw in the concalorimeter or in the SBI.
In my case, that I am interested in European market, which would be the test?
Yeah, for Europe, we have this other facility that, as you can see, it's a bit different because it's not just a front facade, it's also a corner facade. So also this corner is creating like a radiation in the solution, so affects much more to the performance. And here the sample is up to 9.5 meters high.
So all this L shape is the facility?
Yeah, this is let's say the sample holder. Here you will put your solution. No matter if it's a curtain wall-in or an adaptive facade like this case, or ETICS, ventilated facade, you can test everything here. And the issue in Europe is that now we are in the process of creating a new harmonized standard, because fire is a matter of each member state. And right now, each member state has different methods. So we are now looking for just one method for the whole Europe, but this is still developing. And in the meantime, they are proposing to test according to the British or the German standard.
Okay, and is this corner?
And this corner is the British one, for example.
Okay, so now I want to have CIRAF in a pilot building in Europe. Should I go directly for this test after the test we made at material level and product level?
No, I would say that maybe it is better to go to another intermediate scenario, because going directly to the large scale maybe is too much. But now we are in the SBI level, and for us it's like a small scale test. This one, for example, it's a intermediate scale level and an ISO test, where you can test up to 3 meters sample, so quite realistic. And also that the fire that we are putting here, it's around 100 kilowatts. That is 3 times the SBI. So this can give you more idea of how different features, or for example, these barriers can react in the test. And then once you learn something here, you can go to the bigger one, that is the one that will be in the European regulations in the next years.
I see.
Now it's still in a developing phase, but we guess that in some years we'll have this in the regulations.
Okay, so first, material level, we need to check if we need to change something in the formulation. Then we go to product level. Maybe there we have some learnings about the joints, some redesign. And with the optimized version, I can go directly here, right?
Intermediate scale, yeah.
Maybe a bit more learnings and final check.
Final exam will be the big one.
The big one before the pilot building that it's safe.
Okay, that's it.
Perfect, so we will do all these steps. Thank you very much, Javier.
Thank you.